In this video, we'll be talking about using and understanding satellite rigs. We'll show you a basic diagram of the components used to make contact with another ham radio operator using a satellite. Throughout this video, I hope you gain a greater understanding of satellites and find that using them to make contacts is not as hard as may be portrayed. In this video, we'll be using equipment that the Lake Washington Ham Club owns and makes available to members of the club. Even though this video is intended to give you just a basic understanding of satellite communications, hopefully you'll be more interested in this aspect of amateur radio and want to pursue it in the future. To start things off, we have a diagram of all the components we'll be using to make contact over the satellite. First, we have the computer, which will be controlling the position of the antenna and the frequency the radio is using to contact the satellite. The satellite will be moving and changing its position in the sky. The antenna will have to change position also to track the satellite. Here's the antenna as a directional antenna that must be pointed to the satellite. In order to change that direction, you have to have a rotator to be able to change the angle for which the antenna has towards the satellite. And that is done with a controller, and there's an interface between the controller and the computer. So the controller box, in harmony with the computer software, will send commands to change the antenna position automatically to keep it pointed at the satellite while it moves. Now, chasing a satellite is more than just tracking a moving target. There's also the Doppler effect, Doppler shift, that happens to the radio frequency when communicating with satellites due to the observer being closer or farther away from the satellite as it moves through the sky. And because of the Doppler shift, the radio frequency will also need to change slightly as the satellite moves through the sky. The computer software will calculate the change in frequency that the radio needs to be able to automatically contact the satellite. This includes how high the frequency is, since it changes differently for UHF and VHF. It also includes whether it's sending or receiving the signal, since it's opposite on the uplink and the downlink. The computer will also automatically control the frequency changes as they occur and change the frequency displayed on the radio for seamless communication. The connection between the computer and the radio is a CAT cable. Now the radio can be controlled by the computer software, and you'll see the frequency changing slightly on the radio as the software is tracking the satellite overhead. We'll also use a microphone to call CQ and make a voice contact.
Now that all the basics are set up, let's check what satellites are about to pass overhead and figure out which one we should connect to. See how the screen shows the pass that will be occurring and how we have degrees of this pass? We need to keep this above 10 to even have a chance of making a contact. Next, check the clock and see how much time you have before the contact is about to happen. For example, in this screen you'll see we have 1 hour and 34 minutes until the next contact we could possibly make. This gives us time to get a few things ready before the satellite is overhead. Due to the short time that satellites will be available, QSOs are kept short. To be able to make the contact, you'll need to have the following information ready: your call sign and your grid square. Having this information written on a piece of paper, taped to the wall, or next to the microphone can be helpful. A couple things for you to also keep in mind is that we are going to be using the phonetic alphabet a lot more than we would in a normal QSO on an everyday repeater. We do this so, with the interference, people can still understand what information we are trying to pass along. Then, we will use the Maidenhead grid square system as locations rather than a state or country or town, as the satellite covers a lot of territory in a single pass. Get ready by listening to an example of what a QSO exchange and a satellite contact sounds like, and also known as the conversation in which the exchange of information occurs. Instead of making you wait another hour and a half on this video waiting for the satellite, through the magic of video editing, let's just skip ahead for you. Okay, the satellite is here. Let's call CQ.
See if you can get me 6, Uniform Kilo.
November 6th, Uniform Kilo. What is your grid square?
We got his credit card. He needs your information.
DM14, yeah, talking about 14.
So go with
Okay, good.
yours.
Go ahead.
My info is Kilo Golf 7, Golf Echo Victor at Charlie November 87.
Roger, Charlie, November 87. And give me a call again one more time.
Kilo Golf 7.
Kilo Golf 7, Golf Echo Victor.
Kilo Golf 7, Golf Echo Victor. Thank you very much, 73.
Thanks for the QSO, 73.
That's all there is to it. To make our lives a lot easier, we were using the software Ham Radio Deluxe to know when satellites would be passing overhead. Hope you learned a bit about amateur radio satellite operation and the fun we're having in the Lake Washington Ham Club with this mode. Even though this video is intended to give just a basic understanding of satellite communication, hopefully you will be more interested in this aspect of amateur radio and want to pursue it in the future. Thanks for watching, and 73s from KG7GEV.